Good morning, student. Today we are going to discuss nomenclature of coordination compounds. So, coordination compound is basically made up of your metal ion, ligand and counter ion. Depending upon the charge on the complex ion, there are following combinations are possible of coordination compound. So, coordination compound can be made up from simple cation and complex anion. This is your first combination. Second combination is complex cation and simple anion. Third combination is complex cation and complex anion. So now we are basically going to see how the naming of complex ion or coordination compound is done. So basically students should note that first while writing the name of coordination compound, first order is number of ligand, how much ligands, how in a number of ligand is written first. Second, name of the ligand is written. Then name of the metal ion is written, and at last oxidation state of metal ion is written. So now we are going now we are going to see what is how number of ligands, if there is a we are going to see this point, that is number of ligands. The number of specific ligand in a complex is denoted by writing prefix to the name of ligand, that is di, tri, tetra, penta, hexa, etc. However, it is important, however, if the name of the ligand itself contains term di, tri, tetra, etc., then in such a cases the number is denoted by prefix bis, tris, tetrakis, etc. This point is too much important. Followed by the ligand name in a bracket. In that case, we have to write ligand name in a bracket. For example, in case of ethylene diamine, so in this name there is a prefix di is already used. The term di is in the name of the ligand, and if there are two ethylene diamine ligands is present in a molecule or in a complex, then it is denoted by bis into bracket. Name of the ligand is written in the bracket, then ethylene diamine. Now next point is the name of the ligand. Now just see negative ligands. The name of negative ligands may be end in O, ido, ito or ato. For example, now students should learn this by heart. Ligands whose name ends with the O. So just see your Cn minus is written as cyno. Its name is end with O. NO2 is written as nitrito. So its name is also end with O. All halides names are end with O. For example, fluorine is written as fluoro. While writing the name of the complex, fluorine F minus is written as fluoro. SO3 2 minus is written as sulfito. Just see, name is end with O. Ligands whose name is end with ATO. So just see, CO3 2 minus is carbon is written as carbanato, ATO in last. SCN minus it is written as cyanato, ATO in last. CH3COO minus it is written as aceto, aceto. C2O4 2 minus it is written as oxalato, ato. NH2CH2COO minus it is written as glycinato, in last. Just see, name is end with ato. What we are see, it is for a negative ligands. Now we are going to see how the name of neutral ligand is written. They have specific name. Neutral ligand have specific name. You cannot write water H2O as a water. In a ligand, in complex compound, we have to write H2O as a aqua always, NH3 as a amine always, CO as a carbonyl always. We cannot write CO as carbon monoxide. NO as a nitrosyl. C6H5N, it is written as pyridine or shortly PY. NH2CH2 by 2 NH2, it is always written as ethylene diamine. In short, it is written EN. Positive ligands. Positive ligands are very few in numbers and they have their name is end with IUM. So NO plus is written as nitrosinium. NO2 plus is written as nitronium. NH4 plus written as ammonium. N2H5 plus written as hydrazinium. Organic free radicals, they have given their own name. It simply means that methyl free radical is written as methyl, ethyl written as ethyl, phenyl radical written as phenyl. Now we are going to see ambidentate ligand. This question is important. Generally a short question is asked on ambidentate ligand. Those monodentate ligands which have more than one coordinating atoms, that is donor atoms, are called ambidentate ligands. Now just see your Cn minus. Your Cn minus can attach through carbon. Your carbon can form bond with your central metal atom, or your nitrogen can also form a bond with your central metal atom. When Cn is attached coordinated to the metal atom through carbon atom, then it is called as cyno. And when it is attached through nitrogen atom, then it is known as isocyano. It is important. Second is SCN. If your central metal atom is linked by sulfur atom, then it is known as thiocyanato. And if it is linked by nitrogen atom, then it is known as isothiocyanato. NO2 minus. If your central metal atom join this ligand through nitrogen atom, then it is known as nitro N or simply nitro. And if central metal atom join this ligand through oxygen atom, then it is known as nitro O or nitrito. Just see the difference. If it is joined by nitrogen atom, then it is simply known as nitro. And if it is joined by oxygen, then it is simply written as nitrito, ITO. Now what is the meaning of bridging ligand? A complex having two metal atoms is called polynuclear complex. In this complexes, the monodentate ligand likes the two metal atoms simultaneously and is called bridging ligand. Just see in this example, your amine and NO2. These both the ligand joined to two metal atom, that is it joined to this CO as well as this cobalt, not CO. It is the central metal atom cobalt, and it is also central metal atom cobalt. Your NO2 joined two central metal atom, joined with two metal atom, as well as your amine is also joined to two metal atom. So in this case, your amine and NO2 are bridging ligands, and hence the naming the complex, they are written as mu amido and mu nitro. This mu sign simply indicates your ligand acts as a bridging ligand. Now order of naming the ligands while writing the name. All the ligands, whether they are negative, neutral or positive, are named in alphabetical order, followed by the name of the metal atom or ion. The prefix di, tri, etc. are not considered while naming the ligands in alphabetical order. Now next point is name of the metal ion. The name of the metal ion to be written depends on the charge on the complex ion. It is important. That is better, it is called complex cation or complex anion or neutral complex. In case of complex cation or neutral complex, the name of the metal ion is written as it is. In a case of complex anion, the name of metal ion ends with ATE. Just see, if your central metal atom, if a complex with a negative charge, overall charge on the complex is negative, or it is the example of complex anion. And if have a metal central metal atom manganese, then manganese cannot be written as a manganese, it is written as magnetate. Fe can written as ferrate. Co, that is cobalt, is written as cobaltate, and Au written as orate. It is important, ATE comes only in case of a complex anion. In case of complex cation and neutral complex, they simply written as manganese, Fe written as iron, Co written as cobalt, likewise. Now next point is oxidation state of metal ion. It is written as Roman numerical, that is oxidation state of metal ion should be written in the name, and it is written in Roman alphabets in a bracket after the name of metal. Now we are going to see how the name of complexes is written. Now naming of coordination compound having complex cation and simple anion. So just see here, this is the given a complex, we have to write name of the complex. So first of all, see your central metal atom, that is chromium in this case, attached with 4 water molecule and 2 chlorine molecule, but we know that water cannot written as a water, it is written as a aqua, and chlorine cannot be written as chlorine because chlorine is a negative ligand, it is written as chlorido. So aqua in alphabet, according to rule, alphabetical order is followed. That's why this complex name is written as tetraaco, then dichloro, because it contains 2 chlorine. So dichloro chromium. In this complex, chlorine is basically present in 3 oxidation state. Student can easily calculate oxidation state. It is discussed in previous video. And out of the coordination sphere, there is the presence of nitrate. So it is written as nitrate. So name of this complex is tetraaquo dichlorido chromium 3 nitrate. Now naming of coordination compound having simple cation and complex anion. Student should note that if anything written outside of your coordination sphere, if anything present on right hand side, then that name of that species is written at the last. If anything is present before your bracket, then name of that species written first. Just see this complex. So in this complex, there is 5 cyanide ligand joined to cobalt. 1 nitro ligand is also joined to your cobalt, and potassium, it is present as a counter ion and it is written first left hand side. That's why potassium written first. Potassium, now it contains 5, that's why penta, it is cyano, NO written as nitrosyl, and cobaltate 2, Now in this example, just see cobalt cannot be written as cobalt, simply it is written as cobaltate because it is the example of complex anion. Now naming coordination compound having complex cation and complex anion. So this, just see this example. In this example there is presence of two different metal atom, that is cobalt and chromium. So how the naming is done here? So just see here. First we are going to name this side, then we join this site. So it contain this cobalt is basically joined with a 4 amine ligand and 2 chlorine ligand. So it is written as tetraamino dichloro cobalt 3. In this case oxidation state of cobalt is 3. Now here is 6. So that's why hexacyanochromate, and here is 3. Now we are going to apply all the rules, IUPAC rule in positive complex ion. So it contains positive charge here. So just see here, in this complex cobalt is joined with 1 Cl, 2 ethylene diamine and 1 nitro group, but this nitro group is joined with or joined through oxygen. That's why this oxygen written first. So what is the name of this complex, positive complex ion? So just see here, according to alphabetical order, chlorine is written as a first, but chlorine is a negative ligand, that's why it is written as chlorido. Ethylene diamine, its name contain di prefix, that's why it have two, beside that it have two molecule of this, so that's why bis is written and name of the ligand is written inside the bracket. It can be written as ethylene diamine or ethane 1,2-diamine. Since this ligand is joined through oxygen, it is written as nitrito, not nitro. And cobalt is present in 3 oxidation state, that's why cobalt 3 ion. Student should note that since it is an ion, that's why ion is written here. So overall name is chlorido, bis, ethane 1,2-diamine, nitrito, cobalt 3 ion. So in this compound name should be written as tetraaco. Don't write water. Water is written as aco. It is written as tetraaco dichlorido chromium 3 ion. Student can easily calculate this charge. Just student see previous video. Don't write the charge on complex here. It is the oxidation state of metal. The name of this complex cation is tetraamine dichloro or chlorido cobalt 3 ion. You can write chloro as a chlorido. Both prefixes can be used. CO, Cl, En/2, NO2. So it is written as chlorido or chloro bis ethylene diamine nitro cobalt 3 ion. Just see the difference between difference between this formula and this formula. Here your nitro is attached through oxygen, that's why here is ITO is used, while in this complex your cobalt is directly linked with a nitrogen, that's why here nitro is written. Now we are going to see IUPAC name of some complex anion, that is negative complex ion. It simply means that this complex contains negative charge, overall charge is negative. So in this case, first student should note that central metal atom name is written or end with ATE. So now this is the example of complex anion. So it is hexacyanoferrate 2 ion. It is tetrafluoro or tetrafluorido bromate 3 ion. In this case, bromo is written plus, then chlorine is written, firstly amine is written because alphabetical order is follow, then bromine is written, then chlorine is written, then nitro is written, and lastly your metal name is written with oxidation state. So name of this complex is amine, bromido, chlorido, nitro, platinum. In this complex oxidation state of platinum is 2, so that's why overall name is amine, bromo or bromido, amine, bromido, chlorido, nitro, platinate, ATE is written 2 ion because it is the example of anion, negative charge or overall charge on complex is negative, that's why it is end with ATE with metal. So IUPAC name of some complexes containing complex cation and complex anion. So just see here, we are going to write the name of this. So it is tetraamine dichlorido platinum 4 tetrachlorido or tetrachloro platinate 2. It is written as tetrapyridine platinum 2 tetrachloro platinate 2. Now just see here, tris ethylene diamine chromium 3 aqua pentacyanonickelate 2. Now we are going to see IUPAC name of some neutral complexes. So just see here, in this complex there is a no charge on the complex. It simply means that they have zero charge. So they are example of your neutral complexes. So their name can be written as it is tetra because it have 4 carbonyl group, tetra carbonyl nickel 0. In this case it is written as this 0 is not charge on complex. This 0 stands for oxidation state of nickel in the complex. In this case just see, it is the diamine dichlorido platinate or platinum, not 8, it is a platinum because it is the example of your neutral complex. So platinum 2. Here bis cyclopentadienyl C6H5 is written as cyclopentadienyl iron 2. Name of this complex is bis acetyl acetonato oxo vanadium 4. It is known as chloro bis Tu stands for thiourea, copper 1. So in our next class we are going to see Werner coordination theory. Thank you very much.